All right, so here we are on chapter 4 on exponential and logarithmic functions. This is section 4.6 on exponential and logarithmic equations. All right, so using the one-to-one property of exponential functions to solve exponential equations for any algebraic expression s and t, whatever they are, and any positive real numbers that are b is not equal to 1, then we can take b to the s is equal to b to the t if and only if our s is equal to our t. Now, the key thing is our bases have to be the same for the s to be equal to t. So if the bases are not the same, we have to rewrite and then create the same base to a power. So you're going to have to sometimes rewrite the bases so they equal the same thing, and then you're going to have to convert the original t or maybe the original s to something times something else when you change the bases. So that's going to be a key. So if we look here at the first one, 5 to the 2x equals 5 to the 3x plus 2. Well, our bases are the same. We have 5 and 5. So what we can do is we can just say 2x is equal to 3x plus 2. And again, that's because s should equal t if they have the same base. Now we can solve for x. So let's say we subtract 3x. So a negative x equals 2, or x equals a negative 2 when you divide by that negative 1. Okay, and so that would be our solution to this equality. What about this one? Now here we have a 5, here we have a 25. We don't have that other 5. But what is 25? Well, 5 to the 2x equals, well, 25 is 5 squared. That's raised to the 3x plus 2. So what we've done is we sort of got the right base. We have the 5 now on the 5, but it's squared. But what if we took and distributed that across? And so that gives us 5 to the 2x equals 5. Well, 2 times 3 is 6x. 2 times 2 is 4. Now we have the same base. 5 is equal to 5. Now we can set our exponents equal. 2x equals 6x plus 4. Now let's say we take and subtract our 6x. So that's going to be a minus 4x equals 4, divide by negative 4. And so x equals a negative 1. And so then that would be the solution of our original equation. But again, we had to convert to the like bases, so then we could set our powers equal to each other. What about this one? Well, if we look at that, we see that that's 5 to the x. That's fine. Well, this is a square root of 5. Well, what's the square root of 5? Well, that's 5 to the 1/2. Because remember, the square root is to the 1/2 power. And so now in that position, we have 5 and 5. And so x is equal to 1/2. And that was probably one of the easiest kinds you could have. You don't have to do anything. All you had to do is convert that square root to the 1/2 power. Okay. All right, what about this one? Well, this one, we have to think of what values can we take to get to the same base of 2. Well, 2 to the x equals a negative. If I'm going to take 2 here, that's going to be something, and then I'm still going to have that negative. So there's some kind of an issue here. I don't know what's going to work here. So what I'm going to suggest is, well, let's try something we're going to actually learn about here in a little bit, and we'll have it in our tool belt soon, but I'm going to do it now. I'm going to say, well, let's take ln of 2 to the x is equal to the ln of negative 100. So I'm just taking the ln of both sides. That's legal. Now what do I know about that? Well, now I know I can bring that x down, and I have x ln of 2 equals, now I have ln of negative 100. Okay, so far if I'm not thinking, that looks good. Now divide by ln of 2, and so x is equal to this. Now I'm going to plug that in my calculator and see what I get. So I have, let's get out of here, ln of negative 100 divided by ln of 2. I've solved it. Uh-oh, non-real answers. And that's because when I take ln, it always has to be greater than 0. So I can take ln of 1 and I get 0, but I start taking ln of like 0.5, I start getting negative numbers. But if I take ln of negative 0.1, that's when I'm negatives. I can't do that. So I always have to have that greater than 0. So here, x equals, well, there's no solution with real numbers. Okay, so that would be the case here. And so if you think about that, I just took ln on both sides, and then I used the power rule, brought that down, and I was able to solve this. But here, I couldn't think of a way to get the negative 2 to make that work out here. And that's mainly because you can't. There's not a solution in this case. Okay, and so this is kind of the way to show there's no solution. And this one, we could have been batting this around for quite a while and trying to figure out how to make that 2 to what power to make it work so we get the same basis, and you just can't do it. All right, so here, solving exponential equations using logarithms when a common base cannot be determined. That's kind of what we just did a little bit. What we're going to do is we're going to apply the logarithm to both sides of the equation. If one of the terms in the equation has base 10, we're going to use the common log, which is, remember, log. And if none of the terms has a base 10, we're going to use the natural log. And so that would be the ln. And then we're going to use the rules of logarithms to solve for the unknowns. So kind of like what we did here, this is what we're going to do now. And the rules we're going to use are things like this. We're going to take that down. We're going to, divide, things like that. So it's nothing different. And so here we have a 2 and we have a 3. Those are not equal. We can't do anything there. So what I'm suggesting is, and I'm going to use ln most of the time because there's very few times when you're going to have actually base 10 are going to have something with base 10 in here. Usually it's going to be a matter of using ln and doing it that way. And even if you do it with base 10, it's still going to work. You're just going to have maybe one extra step. But what we're going to have is ln of 2 to the x equals ln of 3 to the x plus 1. Now, what did I do on the other one? Remember, I just bring down my exponents here. So that's x ln of 2 and then equals x plus 1 times ln of 3. Okay. Well, now what do I want to do? Well, now I think what I'm going to do is I'm going to distribute here so I can get all of it together. So then I'll have x ln of 2 equals, now I have x ln of 3 and then plus ln of 3. So the ln of 3 times x is ln of 3 times x, and then times 1 is just that. And then what I can do is, okay, well, now I notice I have a common term of x in both of those, so I'm going to take that over there. And so if I do that, I'm just going to subtract x ln of 3, and I'm going to subtract x ln of 3. And so I have x ln of 2 minus x ln of 3, and that's equal to my ln of 3 that's still on this side. Now I can factor out that x, and I have ln of 2 minus ln of 3, and that's equal to ln of 3. Now here I've got a subtraction, and so what I can do is I can rewrite that as ln of 2 over 3 is equal to ln of 3. Now I can divide both sides by ln of 2 over 3. And so that gives me x equals, and now what I have is the ln of 3 over the ln of 2/3. Now, do I want to leave it there, or do I want to, go ahead and do a little bit more work? I could say, well, let's leave it there, or I could actually plug that in my calculator and get a value. So then if I do that, let's get out of here. Let's clear that. So that would have been ln, it was 3 divided by the ln of 2 divided by 3. And so it's negative 2.710 maybe. And so that's going to be a negative 2.710. And so if they ask to certain decimal place, that would be one way. If they ask to leave it exact, you could leave it like that. So it kind of depends on what their thing is. This one just said solve, and so because it said solve, I think that would probably be the most logical. I could leave it here, but if it really wants numbers, I'm going to take it to 3 decimal places and be good. Now what about here? Well, again, I'm going to do the same thing I did up here, except now I just use this equation. So that's going to be ln of 2 to the x equals ln of 3 to the x. Bring my x's down, so x ln of 2, and that equals x ln of 3. Now, I have to take it to the other side, so I'm going to subtract x ln of 3, subtract x ln of 3. And so that gives me x ln of 2 minus x ln of 3 equals, well, when I subtract that off, that just equals 0. So then x times, now I have the ln of 2 minus ln of 3 equals 0. Now let's not get fancy this time. Let's say, well, let's divide both sides by ln of 2 minus ln of 3. And what is 0 divided by anything? Well, 0 divided by anything is 0. So here x is equal to 0. And this one is kind of one of those, if you think about it, 2 to what power is equal to 3 to that same power? Well, there's nothing except for 0. If you take 2 to the 0, that's 1. 3 to the 0, that's 1. That's the only one that logically makes sense, but we've done it using the log rules, and now we can show that, yeah, x equals 0 is the only possible answer. All right, so now looking at equations that contain e, those are going to require our natural log. So that's going to require the ln. And so what we need to do is we need to isolate the e part of the equation and then take the natural log on both sides. So kind of like we've done up here, we're going to take the natural log on both sides, but what we're going to have to do is we're going to have to isolate the e part, okay? So if we want to isolate the e part, what do we do here? Well, we just want e to the 0.5t, so we're going to have to divide by 3. So we'll have e to the 0.5t equals 11 over 3. Okay. Now at this point, we can do what it says here. Take the ln of both sides. Okay. Well, what do we know about power rules? Well, that says, well, we can bring that down front. We get 0.5t ln of e equals ln of 11 over 3. What do I know about the ln of e? Well, if we don't remember, we can always come over here and say ln of e. Now it's to the first power. When there's nothing there, it's just assumed to be a 1. And guess what that gives us? It gives us just 1. Okay. And so this is 1. So now we have 0.5t equals ln of 11 over 3. Now, what is this? Well, that's a half. So if I want to rewrite this, that's 1/2 t is equal to the ln of 11 over 3. And so to get rid of that 1/2, I multiply by 2. So I'm going to multiply by 2. So then t is equal to, well, I'm going to put that 2 out in front now because it's going to be easier. So that's ln of 11 over 3. Now, am I done? Well, except for if we're using all the rules for logs and all that, we would want to take that up to the top. And so that would then be ln of 11 over 3 squared. Okay. And so that would be the key difference between this and this is that one's in the most simplified form. This one has been reduced a little bit because we already took that 2 down. And so we want to go and we want to condense this as much as possible. And so that would be our as much as possible condensed form. All right, what about this one? Okay, well, I see we have e to the 2t, e to the 2t. So if I just have numbers in front of those, I could say, well, let's subtract e to the 2t from both sides. And what does that give me? Well, it gives me 3 equals 7 minus 1 is 6e to the 2t. Well, let's divide by 6. And so that gives me 1/2 equals e to the 2t. Well, now we're at a point where we have the same things we had here. We just take the ln of both sides. Now remember, we can bring that down in front, so that gives us ln of 1/2 equals 2t ln of e. Well, we saw that that was 1, so we just have 2t here. So we divide by 2, and so t is equal to, and we could say that as 1/2, and then ln of 1/2. Okay. Now, are we done? No, because I'm going to say, well, we should take that up here like we did here. And so now that that's going to give us t equals ln. Well, if we're taking this to the half, that means we're going to have the square root of 1. Well, the square root of 1 is 1, but the square root of 2 is the square root of 2. And so then that would be our final answer. And so, if we rewrote that, that was ln of 1/2 to the 1/2. So we're going to take each one of these to the half power. And whenever you take something to the 1/2, 1 to the 1/2 is equal to, the square root of 1, but that's just 1. But when we take 2 to the 1/2, that's the square root of 2. Well, that we're going to leave as a radical 2 down here. Okay. So it's just a matter of simplifying, going through the process of getting it to the most simplified, and in this case, condensed answer as possible. All right, so let's stop there and we'll come back for more.